Hello and welcome. This is your first time seeing this video or this channel. Please try to subscribe, especially my YouTube channel. We are looking at this reference angle, and that is lesson number, I think, 8. And this lesson is just going to focus on the reference angles. And with the reference angles and with the special angles, you'll be able to find some values for some trig ratios. Is that okay? So let's start with this one. Reference angles. What do we mean by a reference angle? Let's say that I have, this is my y, this is my x. We all know that for angles, one thing you should know, angles are measured from the positive x-axis, okay, anti-clockwise, unlike bearing where you measure from the north or the y-axis clockwise. So for this case, when you are measuring angle, you start from the x-axis and we measure. So let's say I have, this is my angle theta, okay. The reference angle here is that you are going to focus on the angle that the terminal line makes with the x-axis here. So the angle that is made here, that's the one we are interested in. Is that okay? That is what we mean by what? A reference angle. So let's say I have let's say 120 degrees. The reference angle for 120 degrees is this. We know that here is the first quadrant. The whole of this is second, third, and fourth. So this is my first, my second, my third, and then fourth. You know that first quadrant is 90, second quadrant is 90, 90, 90. That sum up to 360 degrees. But from first quadrant to second quadrant is 180 degrees. So 120 degrees will actually fall on this place. So that is this, 120 degrees. But to get the reference angle of 120 degrees, we are interested in the small angle that form with the x-axis here and the terminal line here. So the angle that form here becomes our reference angle. And here will be what? 60 degrees, because it will be 60 degrees. That will make this line be 180 degrees. So the reference angle of 120 degrees is 60 degrees. Is that okay? Now let's also look at 240. Say I have 240 degrees here. So I have to draw this, right? Then when I draw this, I indicate where 240 will be. No, 90, 91, 80, 270. So it will be here. Okay. So here our reference angle must be at this place. So from here up to this place is 240 degrees. But the angle that is made with the terminal line, this line, and the x-axis here is what we want. So what would be? Subtract 240 from the, 180 from the 240. And what do we get? So here will be 0. If you borrow and add, here become 14. 14, if you subtract 8 from 40, you get 6 here. You have 60 degrees. So here is 60 degrees. So this becomes the reference what? Angle. Is that okay? So the reference angle basically means that the angle that is made with the x-axis and the terminal line. That is your reference angle. Are we good? So let's look at some examples and how reference angles are used in solving trig ratios or trig questions. Now let's look at this example. Find the value of the trigonometric functions for 210. So per what you have learned, we are going to apply it. So let's see. So I'll draw my Cartesian plane like this. And this is my y, here's my x. I know 210 will be at the third quadrant. And from here to here, we know that it's 180 degrees. So what will I add to 180 to get that 210? So that I will get my reference angle. And that is 30 degrees. So I have it here. With this, I can draw right angle, triangle. Okay. Now, this is 30, 60 degrees. And remember that when we were doing the special angle, we had 30, 60. If you are forgetting, let's see. When we were doing special angles, I drew something like this, where this one was equilateral triangle. And you know, for equilateral triangle, the angles are the same, 60, 60, 60. So if I divide this one into 2, if I, let's say, replace 2 2, you can use any number of your choice, okay? But I'm using 2 2, the size are 2 2 2 2 each. So if that is the case, and I divide this one into 2, I can say that here's 1, here's 1. So I can just draw, let's say A, B, C. So that A, B, C. And when that happens, here becomes 1, here becomes 2, here becomes 60 degrees, right? It's here. And this have divided into 260, so 30, 30. So here is our 30. Now, if I use Pythagoras theory, here I have root what? 3. If you have not, you don't understand anything here, you can visit the special angle at YouTube, Dramani Online Mathematics. Visit my playlist where I've treated the special angle. You looked at it, you understand it. So with this idea, and with this, I can get all my 6 trig ratio for the 30. So I can have sine 30, which is equivalent to sine 210. Actually, that's what we are looking for. Is that okay? Then I can have cos 30, which is also equivalent to cos 210 degrees. That's what we are looking for. Then tan 30, which will be equivalent to tan 210 degrees. Then we have sine, the inverse of sine is cosec. So cosec 30, which will be equivalent to cosec 210 degrees. Then we have cos sec. Sec 30 is cosec 210 degrees. Then last one is cot. The inverse of tan is cot 30, which is cot 210 degrees. Now, before I will pick the values from here, I want us to look at this. Remember that this, I said this in my previous video, this is cast. Starting from here, cos is positive here, only cos, that is positive here. Here, all the trig ratios are positive here. Here, only tan, sine is positive here, and here, only tan. And the inverse, here too, the cos and the inverse, the sine and the inverse are positive at the various quadrants that I've just indicated. So it means that if sine finds itself at the third quadrant, which tan is positive there, sine becomes negative. The same thing applies to cos, becomes negative here. So sine and cos becomes negative at the third quadrant. Just like cos is positive here, so when tan or sine find itself here, becomes negative. Here, when they find themselves here, they are all positive. So in this case, whatever answer I choose for this, because sine is at third quadrant, it becomes negative. So let's look at that. Now, per what I've done, 30 is facing here, right? So it's this opposite this hypotenuse. So sine 30 becomes opposite over the hypotenuse. So 1 over 2. So we have 1 over 2 here. But because sine is finding itself in the third quadrant, we attach negative to it. Same thing applies to cos. Remember, cos is adjacent over the hypotenuse. So I have root 3 over 2, but we attach negative to it because it's at the third quadrant. But for tan, which is opposite over the adjacent, so 1 over root 3 is positive. It's at its comfortable zone, which is the third quadrant, so we maintain it. Remember that this, if you put it in calculator like tan 210, to give you root 3 on 3, because the calculator will rationalize it. Now let's look at cosec. The cosec is the inverse of sine, so we just inverse this, and that gives you negative 2, sorry. Sec, just I inverse this, that gives you negative 2 over root 3. Then cot is the inverse of tan, and that gives you root 3. Is that okay? And this is how we use the reference angle to solve for trig functions like this. As a matter of fact, here if you put this one in calculator, sine 210, you get negative half. Cos 210, you get negative root 3 on 2. Tan 210, you get 1 over root 3 or root 3 on 3, because it has been conjugated, rationalized. 1 over root 3 times root 3. This is how you rationalize. You get root 3 over 3. You get it. So if the calculator leaves that way to you, it's not like it is wrong, but it has been rationalized. Is that okay? Thank you very much for watching, and wait for more.